What would happen if we tracked the pH of the solution? So if you put a pH probe in here, it could read the pH of the solution. So in the beginning, before you added the base, the OH minuses, if only H pluses exist, what would your pH be? Would it be high or low? That's correct. It would be low. So let's say pH 2.0, right? As you add the OH minuses, what would happen to the pH? The pH would keep going up and up and up and up until at equal moles of the acid and the base, you're going to get pH 7. Then if you keep adding the OH minus, the pH will go up some more, and then maybe it'll go to pH 12. So as you can see, as you do the experiment, the pH can change. When we track the pH of this solution, we can put it into a graph. Okay, it looks like this. This would be called a pH curve. Okay, so on the x-axis, we're going to plot the pH. On the y-axis, we're going to plot the amount of NaOH that you add. So let me demonstrate. So in the beginning, let me draw a beaker here. You have nothing but H pluses. H plus, H plus, H plus. The Cl minus is spectator again. So if you put a pH probe in here, let's say this is your pH probe. The pH would read pH 2, let's say. So your initial here, this is 0, right? If you haven't added any NaOH yet, the pH would be really low. This is just the pH of your beaker, whatever is in there. As you keep adding the NaOH, let's say you added 1 mil, the pH will go up a little bit, but not too much. And then you keep adding more and more and more and more. In this picture, you keep dropping some OH minuses. The pH will keep going up, but it kind of stays a little bit flat, but it goes up only a little bit. The reason is you still have more H pluses in the beaker, so it's still acidic. Okay. All of a sudden, when you've added about, it says right here, let's say 16 milliliters of the base, you now have equal moles of the H plus and the OH minus. What do you think is going to happen to the pH? Around 16 milliliters, maybe in this area right here, the pH will go to pH 7. So like right here. So it's going to shoot up to pH 7 because at that point you have equal amounts of H plus and OH minus, the acid and the base. This is called equivalence point. Okay, and then as you keep adding more of the OH minuses, so here you're adding the OH minuses. Right now it's canceling. Let's say you have 1, 2, 3. So this cancels with this cancels with this cancels with this. So you have 3, that's the equivalence point. As soon as you add one more drop of OH minus, you're going to have OH minus in here. The pH will shoot up really high right here, maybe pH 10. And then it'll start to plateau again because now you have mostly OH minuses. So if I drew a line through these points, okay, just a smooth curve, this is called a pH curve because it looks like a curve. It looks like an S curve, and it's the pH values. Okay. So here are the titration curves. This is a titration curve as well. First, the pH starts low because you have mostly HCl. The pH increases slowly as you add NaOH. Suddenly, the pH goes up to 7 when H plus equals OH minus. Is called the equivalence point. And the equivalence point is when the moles of H plus equals OH minus. Okay. Now, how do you know that you have reached equivalence point? What you need to do is you need to add an indicator, just we show here. In this diagram, we use phenolphthalein as the indicator because phenolphthalein changes color, if you can look at this image here, you have phenolphthalein right here, phenolphthalein right here, and if you look here, it's white, white, white up until it hits around pH 8, and now it's now lilac purple, and then it goes to fuchsia pink. Okay, so we used phenolphthalein because, let me show you the diagram, because the change of color can happen anywhere in this area. As long as you know the changes color here, you can just go down. This is where it changes color. You added about 16 milliliters of base, and you can just go across, and you can say it's pH 7 right there. Okay. Okay. So for this is a titration of a strong acid with a strong base. When you have both of them strong, let's say HCl and NaOH, you're only going to make salty water, NaCl plus H2O. Your pH at equivalent point will be neutral, will be right at 7. So you want to pick an indicator that changes color around pH 7 or pH 8 because it's in the steep part of the curve. So phenolphthalein will work. Now, if one of these is weak, then the pH here might change. Let me demonstrate. Okay, so here you have HCl and NaOH. H plus OH is water, and Cl minus plus NaOH is, Cl minus plus Na is NaOH. So what you're doing here is your unknown is the OH minus. Your unknown is the H plus, and you're adding drops of OH minus. So your pH curve would look like this. In the beginning, it would be low because it's HCl, and then it would go up and over. And this pH at equivalence point will be pH 7. Okay, that's if both of them are strong. Okay, what if the acid or base are not strong? Then what you need to do is you have to do something else. So this, let's say this is NH3, and this is a strong acid, and this is a weak base. Okay, when you react these two, the H plus will go to the NH3, becomes NH4 plus, the ammonium ion, and the Cl minus. Okay, so let's look at the spectator ions here. When you let's look at the conjugate pairs. HCl becomes Cl minus. This is this acid. This is now its conjugate base. Okay, and if you have a strong acid, this base will be weak, because strong acid means the H plus will come off, which means the Cl minus doesn't want it. So the Cl minus does not want the H, doesn't want H plus, so it is a weak base. Now let's look at the NH3 and the NH4 plus. These are conjugate pairs, NH3 and NH4 plus. This is the weak base, this is the base, this is the conjugate acid. If this is a weak base, then this conjugate acid will be strong. It's not per se one of the top 7 strong acids. It's just a stronger acid than it is its conjugate base. So it's a strong acid, which means in the end, your solution will be a little bit acidic at equivalence point because you have a strong acid in there. Here we have neutral. This is NaCl, I'm sorry. They're both neutral, therefore you're going to get pH 7. For this one, we're actually going to put the NH3, there's something weak in the bottom of the beaker, and we're going to add, we always add something that is strong because you know it's going to react. So in the beginning, your pH will be high because it's NH3. As you add the acid, it'll go down, and then it'll go over like this. Okay, so your pH at equivalence point will be a little bit acidic, so it'll be around pH 6. Okay. If your equivalence point is at pH 6, you want to find an indicator that changes color around pH 6. So maybe right here. Let's use bromothymol blue. It's yellow to teal at around pH 6. So here, you want to pick an indicator that changes color at the steep part of the curve. So you have many choices. Okay, let's do another scenario. You have a strong base here, and you have a weak acid. This is vinegar or acetic acid. So you're always going to put the weak substance in the bottom. Okay, so the weak acid is HC2H3O2. So your pH curve will start low because it's a weak acid. It's an acid. And then you're going to add the base, OH minus. So as you add the base, it's going to go up. Okay, the pH at equivalence point, can you guess, is it going to be acidic, basic, or neutral? To do that, you're going to have to see what reacts. So the OH minus and the H plus will turn into water, plus C2H3O2 minus. This is the acetate ion. Okay, let's look at the conjugate pairs. So this is the conjugate paired with this substance. So this is a weak acid. Its conjugate base will be stronger than its conjugate acid. So this is strong. Because you have a strong conjugate base, your pH will be a little bit higher at equivalence point, something higher than 7. Okay, so let me just review what we did. What we did here is this is called a titration curve. This is a titration curve for when they're both strong. When they're both strong, you get salty water. The pH is 7, okay, at equivalence point. Okay, equivalence point means you have equal amounts of this acid and this base. Okay, you have an indicator. You need to pick an indicator that changes color at around this area. By the way, there's something called endpoint. Not to confuse this with the equivalence point. Endpoint pertains to the indicator itself. It is when the indicator changes color. pH at which indicator changes color. So you want the endpoint to be close to the equivalence point so you can see a color change. Here we learned about the different scenarios. If you have a strong, both are strong, your pH will be at 7. If one of them is weak, then whatever is weak will make something strong. In this case, it'll be stronger. A weak base makes a strong acid, so it'll be acidic. Here you have a weak acid turn into a strong conjugate base, so it will be basic. Okay. One additional thing, you can also calculate the pH at equivalence point by taking this point and this point here. Let's say this is around pH 2.5, plus taking this point, maybe it's around pH, or maybe this point 11.5. Adding them, dividing by 2, and you can get pH 7, and that will be your pH at equivalence point.